Hey everybody, sorry that it was short notice, but I needed to take a day. I will see you tomorrow. Let's do this quick. It says independent practice, but I'm going to go ahead and do this train question with you and let you get started on your own. Okay, it says the Webster family lives 120 miles from Washington, D.C. They take the express train when they travel to D.C. The train travels at a constant speed and makes the trip in 2 hours. And they set up this table for us. Thank you very much. In 2 hours, they can go a distance of 120 miles. And they even set up a little blank right here so we could find the unit rate that in 1 hour, the train will travel 60 miles. So we have to fill in the rest of this table according to that 1 to 60 ratio. So if 1 hour is 60 minutes, 2 hours is 120, 3 would be 180. And you look for that relationship to get from time to distance, and it looks like the distance between the time and the relationship between the time and the distance is that the distance is whatever the hours are times 60. So let's just write a quick description there. Distance is hours times 60. Or you could say 60 miles per hour. What is the unit rate for this scenario? Well, let's just use what I said. 60 miles per 1 hour. Okay, let's keep going. We need 3.5 hours. Now I know 3 hours is 180 and 1 hour is 60. Let me come up above and figure out what would a half hour be. Well, if 1 hour is 60 miles and a half hour is 30 miles. So 3.5 would be 180 plus 30. That would be 210 miles. Okay, then they give us 240. So what I'm going to do is look at these distances and try to find one that'll jump to 240. I could go from 30 to 240 times 8. I can go from 60 to 240 times 4. I could go from 120 to 240 times 2. However way I decide, I think I'm going to do, I like the times 2. 2 times the distance means I got to take those hours and times them by 2. So that would be 4 hours. And then I've got 5.5 hours. Now I could take 5.5 times 60 because I know going this direction it's times 60 and going this direction is divide by 60. So I could take 5.5 times 60, or maybe I could take 4 hours plus 1 hour, that would be 5, plus a half hour, that'd be 5.5. So what's 240 plus 60? That's 300, and plus another 30, 330. So there are clues in the table that can help you find missing amounts. Are the rates represented in the table equivalent? Yes. Do you know why? They all have the same multiplier. Have the same multiplier. M-U-L-T-I-P-L-I-E-R. Sorry, I'm bad at spelling, so I have to think it out. So to get from the time to the hours, they are all exactly times 60. How would you use the table to find the time it takes to travel, the train to travel 420 miles? So I would look on here and try to figure out what can help me get to 420. My brain automatically sees this 210. If I double it, I get 420. So if I take 3.5 doubled, I get 7. That's one way. I'm sure there are other ways to get to 420. Maybe take 60 times 7 is 420, so 1 times 7 is 7. However way you see it, find it, and then write it down. So what I saw was double 210 miles equals 420 miles. And then double 3.5 hours, or I could have said times 2, and you get 7 hours. Boom. So there are clues in the table that can help you quickly find other answers. Okay, let's move it on down to the graph. I love a graph. Graphs are the best. Okay, graph the values from the table. Use time as the x and distance is the y. So here's my time in hours. There's my distance. Okay, so from the graph above, I'm going to do the half hour. The half hour is right here between 0 and 1. And if this is 0 and this is 60, this would be 30, this first line. So a half hour is 30. 1 hour is 60. Then we've got 2 hours goes up to 120. 3 hours goes up to 180. Then they did 3.5 hours, which would be right here. 3.5 is 210. 210 is right between 180 and 240, so follow that up. There we go. Then what was the next one? 4 hours was 240. It's following the same linear trend here. 5.5 hours, so that would be out here, is 330, way out here. And then if we had to extend to 7 hours, it'd be like up here, but we're not going to have to do that. Does it make sense to connect the points on the graph? Well, can I have fractions of time? Can I have a half hour, a quarter hour? Yes. Can I have fractions of distance? Can I have a half a mile, a quarter of a mile? Yes. So does it make sense? Yes. Why? Because we can have fractions of time and distance. I'm going to write that down. We can have fractions of time and distance. All right. Let me go ahead and draw that line as best as I can. It's hard to draw a straight line or a perfect circle. There. Yeah, that's not bad. Mandy says that in 2.5 hours, the express train can travel 150 miles. Is she correct? Well, the greatest thing about having a graph is you don't have to do math, because you know I like to avoid doing math. Let me see real quick. Give me a second. Okay, I went back to my desk to get a highlighter. So if I use my highlighter and I find 2.5 hours right here, and I follow it right up to this trend line that we created and carry it over this way, it's between 120 and 180. Is that 150? 120, 130, 140, 150. Yes. So that is 150. So is she correct? I'm going to say yes. Explain. See the graph. Slash line. Okay, so whenever you want to explain by showing something on the graph, you have to show me on the graph what you are talking about. 2.5 in the hours, followed up and over to 150 on the distance. Okay, Jake says that the express train can travel 300 miles in 5 hours. So if I go 5 over to 300, does that work on the trend line? Yes. And again, see graph. But you have to show me on the graph what you're talking about. Okay. H. How would you use the graph to find the distance a train travels in 6 hours? Well, that's easy. I would just take 3 hours, which is 180, and I would double it to be 180 doubled is 360. So double 3 hours to 6 hours, and then double 180 miles to be 360 miles. But there's more than that. You could also take 5 hours plus 1 hour, which would be 300 plus 60, 360. You could take 2 hours, which is 120, and triple it to get 360. There's lots of ways you can do it. So whichever way you see, write it down. Okay, now what you're going to do is work on the next set of problems. Okay, let me zoom out. Sorry, it doesn't zoom that far. So practice number 2 is regarding candles. Practice number 3 is the length and width of a sticker. Okay, and practice number 4 is sweatshirts and money. Question on number 4, can you have a fraction of a sweatshirt? Sure, but would anybody pay for it? No. So decide if it makes sense to connect those dots or not. When you're finished with that, look up at the front. The answers are posted. If you don't finish in class, that's fine. Go ahead and take it home. Bring it back tomorrow, and you can check your answers up at the front. Okay. You may listen to your own music while you're working on the rest of this. Have a great day, and I'm sorry I missed you. See you tomorrow.